So we're here to talk through this interesting Nurikabe by Mark Sweep called Ones with these 6 clues. Not only do they all contain a 1, but you'll notice they're all on the border of a grid. And in Nurikabe, that's a pretty important constraint. It's something I hope this Tuesday puzzle teaches you if you haven't seen before. Here's one thing that's true when you have border islands. If an island comes off the border, it's not coming back to a border. So here's an example of what looks like a valid 11 cell island, but any of these cells that are part of this ocean cannot be connected. They can't go around the border of the grid to get back to the rest of the oceans around here. And so this constraint, when you pin an island to a border, it only will have one touch point to that border. And that's even true of like an internal island cell. If the clue were here, but the island somehow reached to here and reached to here, you'd cause an issue. So here just an island already starts with that pinning. And so we'll keep that in mind as we get started, as the author intended probably in the upper left. These 11s have an ocean between them. This has to come out. This now collides with this island. So more ocean, more island, ocean, island. This collision down here, which is going to push in more ocean, island, and so on to get the start. Similar collision over on this side, and this may be a good time to actually shade these groups in different colors, because we're going to use some color thinking for the island identities to help here. So let's at least make these 11s in different colors. I'm going to keep the green in the upper left. Two things to do here. One, which is maybe a little more advanced, but something that I like to keep track of, is to start to get an intuition for where cell packing is going to be challenging. And these are all big island groups. So one thing to think about is, how do we reach into this upper right corner? Can we take, for instance, these cells with this 11? And if we did, like, how does this 10 work out? Well, a 10 can take a pattern like this, but it really is going to force this to be an ocean cell here. So we're not reaching all the way over to here. If we even did something like more compact but came down this way, we're then still taking now this cell. So this cell looks like a key cell for the 10. There's no way the 11 can take this cell for sure. And if this cell is taken by the 10, that means that the 11 group above has to come down this channel. And so this cell for the 11 and this cell for the 10 are two very key cells, and they're almost the extremes of things that can't be taken. And so one way I will sometimes notate this, I'm going to turn on edge helper, which isn't usually in a Nurikabe style, but helps this, is there's kind of an ocean that has to sit between these islands, and it has to sit between this channel in this space. That could mean this, it could mean just this. Actually, it can't mean just that. You'll see that doesn't have 10 cells for it, but conceptually there's a blocker here. And keeping that in mind will be useful to know that right away, for instance, one of these cells has to be part of a 10 group or an 11 group to avoid the 2x2 rule, but it's got to come from this island. And similarly, we're going to need a green cell up here from this island to mark off some of the space. And that will suggest that this blue group is going to be coming down more to make this work. So a little bit of crowding in the top is something to observe, but I think the author's intent and where we're going to go next is down this lower left corner, where we have another space where we don't want to have all of these cells as oceans. So at least one of these has to be an island, and you can't reach this cell without taking this cell. So we really need to think about these two and say, can any of these be part of one of the islands up above? If red was part of orange and came down like this, to take this cell, it would surround and block these islands, which is no good. This ocean at the top. And this similar thinking, but for this ocean, is true if this comes over and touches any other group like this 11 in yellow, that now this ocean can come below but can't get around this grid. And so this cell, curiously enough, this is something that people who watch our cave solving videos will see, is forming a checkerboard pattern, but in a Nurikabe puzzle where this is an invalid pattern because all the islands are already touching the edge cells. So you're effectively making it so that you need to have this joined to another border, but in doing so, it's going to isolate this group or this group. So there's a organization of the grid that makes this impossible. So instead, this is an island cell down here. And can this cell be part of the red group? Well, as we said, the start's already on an edge, so it can't come back to an edge. So the only island that can actually come to this is one that follows the whole edge to get to it, which would be something like this 11. And if I actually count the cells, that's exactly 11 cells. So it turns out that looking in the lower left corner gives you exactly the shape of this 11 island by the time you try to reach to it. We now have some more cells to think about, and let me go to a color that's not one of the, actually it's probably easiest to take this and keep these green. This 11 can reach over to this cell. This 11 can't. So what we really have to think about is, can this be part of the orange group? and for instance have this pattern in the grid. And if that's the case, we now have to get these 7 cells to take 4 more, and this 11 group to take 6 more, and we don't have 10 cells here, and that's not even thinking about the ocean that's going to come between. We've got 9 cells here, so if like this blue came this way, we're just not leaving enough space for the group. So seeing that this is part of the red group actually gives you an exact way this island goes as well, because we now have 5, max path of 7, math packs of 11. The most efficient, I should have said min path, 5 to 7 to 11. So if these come straight and these come straight, we take 11 cells, and anything else would be extending that minimum path. And so this is how these cells get into the grid, get the ocean around them. 2 more forced island cells from the 2x2 rule. And we should see by crowding that there's no way this first one can be any color but blue. If this were part of the orange group, then we don't have enough room up here, particularly now that we've marked these exclusionary cells. But notice another situation, if I take both of these as part of the 10, I'm effectively now forcing this to be the channel for the ocean to come together and get around this island, but I'm now leaving just 9 cells for the blue here. So again, another case where we've got to identify what island this belongs to, and it can only be part of this group. So now we've got 7 to here, 9 to here, and 11 to here min path. So this has to come to the left, this has to come up. Put these cells in. We need this ocean to be connected, so we've got to take the cell and we leave behind just enough for the 10 to fit in. So some advanced logic for a Tuesday, but I think good teaching logic for a Tuesday. So hopefully if you worked your way through this grid, you got a sense of how to not just take the easy starts as given, but think about 2x2 gaps, what cells can become island cells, like this cell in the 10th row, second column is a good first aha moment, but it sets up another chain island, a second chain island, and then just leaving just enough space for the last island, where again, we're packed around the edges of the grid. We're not really reaching back to edges of the grid. And we get to this satisfying answer. So thanks, Mark, for the puzzle. Thanks for watching this video. Hopefully you got something from it, and we'll see you again soon.